So back to this problem here, we played around with it by doing what I was called the easy way. And the question is, how did I know it was the easy way? And the answer was, well, I did it before and I did the hard way first. And then I thought, there's got to be an easier way. And I found it. So let's look at the hard way, which I think most people would probably take. So we had this equation for a circle, x minus the center x value 2 squared plus y minus the center y value squared. And it's always going to be a minus in here. Sometimes it'll simplify if we subtract a negative, but because we're looking at the distance between the center and some point, and a distance is a subtraction in math. And that's equal to our radius squared, which ended up being 25. Then we were looking for y-intercepts, so we let x equal 0. So that gave us 0 minus 2 squared plus y minus 3 all squared equals 25. And the obvious thing to do first, I think most people would realize, is say, well, 0 minus 2 is negative 2, and negative 2 times negative 2 is positive 4. And we get to this point right here. And rather than what I did earlier in the previous video, I think most people would say, well, let's square the y minus 3. And then you got to keep in mind, to square something means multiply it by itself. So that really is a y minus 3 times a y minus 3. Remember, you cannot distribute a square through subtraction or addition. And if you multiply that out there, you're going to get y squared minus 6y's plus 9. And we have all this other stuff hanging out. So good practice in algebra from a previous course. Next thing to solve this, we would add like terms. So the 4 plus the 9 are the only like terms I have left on this side. So 4 and 9 is 13. And then you were probably trained in a previous math class that if you have a square and a single powered variable here, then you should probably get 0 on the other side. So we'll subtract that 25 over. And so then I'm going to end up with y squared minus 6y. Let's see, 25 minus 13 would be 12, but it should be negative 12 equals 0. So this is a little different again than I did the previous time, but I get to this point right here, and then you have two options from here. You could either use the quadratic formula. So let's make a note of that. Quadratic formula. Quadratic formula says if you have something that looks like ax squared plus bx plus c equals 0, then x has to be negative b plus or minus the square root of b squared minus 4ac all over 2a. And I do happen to have something that looks like this over here, but there's y's instead. Right? So for my problem, a is 1, b is negative 6, and c is negative 12. And so then I just plug in here with a y equals instead of an x. So negative b, so that'd be the opposite of negative 6. That would be positive 6. Could worry about sign errors, one of the most common mistakes we humans make. Square root b squared, so negative 6 times negative 6. I feel comfortable doing that in my head, but sometimes I'm overly cautious about that. The minus 4ac I'm going to write down. I'm not going to do that in my head. Minus 4. A is 1 and c is negative 12, all divided by 2a. I can do that in my head. So just a note, when I'm doing the quadratic formula, I generally am very cautious right here, because that's one of the most common places I mess up. Maybe you guys too. Let's see, a negative times a negative is a positive, right? Negative times a negative is a positive. So negative times negative is a positive. 4 times 12 is 48. So really what I have right there is 36 plus 48. Okay, so this simplifies a little bit. I get 6 plus or minus 36 plus 48, what is that? 8 and 6 is 14, carry the 1, 84. I get the square root of 84 all over 2. That does not look like my answer over here. Okay, so generally with the quadratic formula, we have a little more work to do. So then we have to try and reduce this. So is this an exact answer? Yes. Is it simplified? No. So I have to mess with the 84. So usually I make a factor tree next, unless I have a calculator that reduces roots. Some of them do. 2 goes into 84, 42 times. 2 goes into 42, 21 times. 3 goes into 21 7 times. So what I see here is that I can factor out a pair of 2's, which is what a square root looks to do. So now I get 6 plus or minus 2 times the square root of 21 all over 2. And 2 goes into 6 and 2 goes into 2. So I can reduce this one more time. 2 goes into 6 3 times, 2 goes into 2 once. So I get 3 plus or minus the square root of 21. That was a lot more work than this one over here. But the question is, how do you know what's the easiest way if you haven't done both ways? Right? And the answer is experience, unfortunately. So sometimes you're going to do things the hard way, and that's okay. You might look back and see if there's an easier way. So here's the answer using the quadratic formula. I'm going to look at this one more way. I'm going to review the idea of completing the square. To do that, I'm just going to pick up from this spot right here. Okay, so let's suppose I did decide to square that out. And I continued with my work here. I got to this point and I'm thinking, oh, I'm going to complete the square, which is something I expect you to know how to do. So let's get a new page. So I believe that y squared minus 6y minus 12 equals 0. Let's double check I copied that right. No, looks good. And so what I'm going to do here is I'm going to use a technique called complete the square. All right, so complete the square says isolate the terms with the variable in it. So I'm going to move that 12 over to the other side. So y squared minus 6y, leave some space, equals positive 12. Then what we do is we focus on the coefficient of the variable with the power 1 here. And so I'm going to call that my b. B is negative 6. So complete the square, what you do is you take your b, it's a b, not a 6, and you divide it by 2. So what is negative 6 over 2? It is negative 3. And then what you do is you take that b over 2 value and you square it. So negative 3 squared is 9. And it turns out 9 is a magic number. It's the number I want to add here. And to keep things balanced, I have to add it there too. Okay, so I built a perfect square. So my claim now that this side right here is a perfect square, it is the square of y plus whatever this number right there is. So I'm going to say it's y minus 3. Okay, so completing the square, take your middle coefficient, divide by 2, square that number to figure out what to add on both sides. The halved number here is what goes inside the square. And now on the other side, I get what 9 plus 12 on a good day is 21. And now I have a perfect square, and this is easy to solve by just taking the square root of each side. So y minus 3 equals plus or minus the square root of 21. Add the 3 over, y equals 3 plus or minus the square root of 21. So what was the least amount of work of the 3 methods I picked? Well, obviously the first one was because I did all 3 and I said, well, look, this one's easier to do. But again, you don't know what the easy way is until you've done it multiple ways. But these are all things I expect you to know. I expect you to know how to complete the square. I expect you to know how to use the quadratic formula. And I expect you to sometimes know there's other ways to solve a problem. Will you always pick the easiest way? The answer is no. If somebody gives me a new problem, I will usually not pick the easiest way first. I will only know there's an easier way if I try multiple ways and then compare them. So sometimes our work is going to be a lot of work, sometimes it's not, depends on the day. Did you have enough oatmeal this morning? All right, next, we're going to take a look at some homework problems.